Hi guys, welcome to the new video. Do you know that there are some numbers that actually comes up very frequently in nature? It might be just the number of petals in a flower. If you see the number of petals in a flower, it usually lies around, it usually basically happens to be three or five or something on that order. Sometimes, or even if you see, say, a cone, you would also see that the number of all these small pieces that you see in the pine cone, they actually belong to a very specific sequence. Similarly, if you see a sunflower and if you basically try to count the seeds in the center of the sunflower, then also you would see that the numbers actually correspond to a very specific pattern. So this is actually is a very famous pattern and is also known as Fibonacci sequence. So it is named after a mathematician called Fibonacci. Obviously, it's a pattern that actually occurs in the nature. It's not that he invented the pattern, but it's a sequence or a pattern that actually exists in nature as well. We won't be actually going too much detail into why this occurs or something like that. We basically will be trying to program it, like trying to find out how you can get to certain numbers. So just to give you a context how this numbers goes. So usually the number starts with 1, uh, and the main rule that govern this sequence is if you go along the sequence, any number would be the sum of the previous two numbers of that particular sequence. Okay, just again repeating the sum. So if you just go along the sequence, if you just trying to finding out any number in the sequence, it would be the sum of the previous two numbers in the sequence. Just to give you just to show you how it is basically happens. So sometimes people start with 0 or sometimes they don't. It doesn't actually matter a lot. If you just think, okay, if there's nothing in front of 1, how do we basically say, okay, what would be the next term? We again call it, okay, since there's nothing, let's add another one. Or you can start with 0 and then it makes sense. Okay, then the third term will be, so if there is say for example 0, then the third term will be the sum of these two, and that would be 1 again. The next term would be the sum of these two, 1 and 1, which becomes 2. The next term would be the sum of these two, which would be 3. Then similarly, sum would be 5, similarly 8, 13. Now you get to see the pattern, right? 21, then 34, and so on and so forth. So every term you can get that term by adding the previous two terms. That's how Fibonacci sequence basically goes. Okay, so so in some places you would see it starting with 0, or some places you would see starting with 1. So just for our scenarios, we would basically take this one where we think the first term to be 1. Okay, and now we would basically learn how to program this. So if you are following the series in the Python programming, we have already covered how to basically program if else conditions, and also we have covered how to basically program loops. We have seen loops using while loops, we have seen using while command, we have seen loops using for command. So we have seen these basic elements of programming, and now we are doing something a bit complex and basically try to understand how these small things can come up and make something much more complex. In this video, there would be two parts. The first part, we will try to very simply actually try to just code the Fibonacci sequence. And by code or by programming Fibonacci sequence, what I mean is that if I want to find out any of the Fibonacci sequence, let's say I want to find out what would be the ninth term in the Fibonacci sequence, or say 15th term, as you have seen, to basically get the Fibonacci sequence, we have to sum up the previous two terms, right? So we don't want to do that manually. We just want that we want to do that programmatically, so that we just say, okay, I want to find out the 10th number or 15th number or 200th number, because obviously this exercise gets a little complicated the far you basically go along. So we want to do that programmatically. We want our computers to finding out what would be the Fibonacci sequence, or basically what would be the nth term basically. So given an input n, we would be trying to find out what would be the nth term. Okay. Now, as I was basically saying, we would be visiting two approaches, and without further ado, I would start. The first approach would be very simple, which is a bit computationally expensive, and this also basically introduce another concept called recursive function. So let's start. So I am in, as you can see, I am in Visual Studio Code. Over here, I have a demo.py opened up. Now let's start actually writing code. So we need to basically define a function. So we would define a function and we will call it fib. Very original. We would call it fib. And obviously it would take an input. What the input is we want to basically input an integer, say n, and what we want as output is the nth term in the Fibonacci sequence, right? So we start with fib n. Okay, and we would be returning some value, just writing return or value anyway. Okay, now what we know about how Fibonacci sequence happens, we need to define the first couple of terms, right? And as I have told you that I would be considering that the first term of Fibonacci sequence is 1. So we are not considering it from 0, we are considering it from 1. So if you just look at the sequence, so usually it goes like 1, 1, 2, 3, 5, 8, something like that, right? So what do we need? We need at least two terms to be defined. So we start with if. So we need two conditions to be satisfied. The first one is if n, which is the input, is equal to 1, and just reminding you guys that if there are two equals to's, basically it is a sign of equality, right? You basically testing out whether some number is, or a variable is equal to some number or something, a string or something like that. 1 equals to sign basically means an assignment. 2 equals to sign basically is a test of equality. So if n equals to 1, then the value which we are returning should be 1. Okay, clear up until now? So if we are trying to finding out the first number, we basically are defining it like, okay, if you are trying to find out the first number, it should be just 1. That's all. Then we have another condition, and you know how we write multiple conditions. So we use elif. So the first condition you write with if, the second condition or third, fourth, the next conditions you write with elif. So elif n would be equals to 2. Again, we want to define for at least two n values. Again, we know what's the value should be. It should be 1. So again, the first term should be 1. The second term should be 1. Now, what else? We can write elif or we can write else, because we always want n to be greater than 2 now. So we have defined 1, we have defined 2, and now we are expecting that n should be greater than 2. Obviously, you can actually make it much more better. Like you can use a condition where you say, okay, if n is less than 1, then you say Fibonacci is not valid, right? So we can start with that as well. So let's actually do that, because that would be a much more valuable lesson as well, how to catch errors. So we are trying to define from 1, right? Because it doesn't make sense if we trying to find out minus 2th number. It doesn't make any sense. So if n is less than 1, which basically starts from 0, if n less than 1, you return you print or you can even say val. It's not that you can't return val, you just say val and you put a string over here that it doesn't make sense. Okay, just a warning, since I am using a single colon to write doesn't, so I should actually make a double quote here so that uh, the interpreter understands that what I'm trying to say is a complete string, right? So I put a val over here. Now then it would be another elif condition that uh, if n is less than 1. So I am basically covering all cases, right? So I am covering all the cases for integer. So if someone basically puts out 0 or any negative numbers, it should return that it doesn't make sense. Then if it counts as 1, then the value would be 1. If it's 2, then again value would be 1. And now else, this is very crucial. Now if n is greater than 2, like say for example the third term, what is the third term? Again, going back over here, the third term is 2, right? But how you are getting this 2? You are getting this by summing up this 1 and 1. So this is what we need to do. Else, val should be val equals to, and this would be a very interesting thing. It would be fib of n minus 1 plus fib of n minus 2. Okay, and return val. So the last line is very crucial to understand, and this is basically the crux of the problem. When we want to basically program something, we won't know beforehand, like say for example, what would be the fifth term, sixth term, seventh term. But we actually have to calculate that because that's how Fibonacci sequence goes. You can't actually come at say 13th position if you haven't actually found out what would be in the 11th and 12th position. Again, to finding out the 11th and 12th position, you need to know the previous two terms, and by this you have to come back to the starting point or the base cases, which is the first term, second term. So obviously you need some kind of recursion going on, right? Recursion means like Fibonacci of n minus 1. It should be somehow related to the Fibonacci of n minus 2 and Fibonacci of n minus 3, as you already have probably understood, just showing you in the picture as well. So if you're trying to find 8, it should be the result of sum of 3 and 5. Now how do you get 3? 3 is also in the Fibonacci sequence, and it is basically the n minus 2th term. So if you are thinking about finding out 8, it will be the if it is the nth position, so it is the n minus 2th position, and it is the n minus 1th position. So that's how you can find out the nth position to sum those two up. So this is how you should write. Right now you have completed the function. So again going back, so Fibonacci n, if n less than 1, you say val, just let's remove the additional space. Okay, val it doesn't make sense, and then val becomes 1, val becomes 1, and else val equals to fib n minus 1, fib n minus 2. Since inside the function fib we are again using fib function, that's why it's called a recursive function. Okay, and just to see whether we are doing it right or not, let's also print one thing called fib of say 5, fib of 5. Now let's save the file. Let's see if we have done anything wrong. So you know how to run a Python file. You just write Python or Python 3 and write the name of the file. So it's called demo.py. And if I say, you see, I got returned a value of 5. Let's check now. If I go here, over here, so as I have told you, so we have put 1 as the first term, then second term is again 1, third term 2, fourth term 3, fifth term is 5, right? So we have gotten it correct. So we wanted to find out the fib 5. Can we find out a bit later on, like fib of 10? Again, try to just save, run the file. We got 55. And I guess we have done that as well. Yeah, so we haven't actually gone up to that point, but this would be 8 would be 6, 13 would be 7th term, 8th term 21, 9th term 34, and obviously the 10th term would be 21 plus 34, which is 55. So yeah, we are getting this right. And just to see the corner cases as well, say if I have fib of -10, what would happen then? Fib of -10, it should give me, it doesn't make sense. Okay, so everything works out very fine. So we have actually created a function. We have built a function which can calculate the nth term of the Fibonacci sequence. So just by using conditions, if else conditions, we have defined a function which can output the nth term of Fibonacci sequence. So that's how we have already started doing something interesting with just if else conditions. But now, so this is the end of the phase one, and you can probably wrap it up if you want. But we want to go a bit further ahead, and this has nothing to do with whether our function is right or wrong, because you have seen, right? I have tested it for like 3 4 cases, and every time I am getting the right answer, which usually means like, okay, what I have defined, or how I have defined the function is okay. But now there comes a problem, and the problem you would probably will be seeing if you try a very higher value as an input. Like say for example, instead of 10 or 5 or 7, if I just say put 50, Fibonacci of 50. Now if I run this code where I am trying to find out the Fibonacci, the 50th term in the Fibonacci sequence, you would see that the function would be running for all eternity. Like it would be running for a very, very long time. Let's just show you. So now I have changed the, so I'm basically trying to find out the Fibonacci term for the Fibonacci sequence term for the 50th. And let's try to run it, and you see that we haven't got any result. So usually if you get any result, the terminal automatically returns that, and if it doesn't, so obviously it's running because you also are not seeing the prompt. So the program is running and it is not returning us any number. Why? Because for fib of 50 there has to be a lot of computations. But not only that, the way we have actually defined this function, we are doing some steps multiple times. Okay, we are doing some steps multiple times, and this is very, very important, because not only you are interested in getting the right answer, but you also want that in a proper time. You don't want your program to be running for eternity. You want your program to be finished. You want your program to be optimized. So that is a very I would say important term, that your program needs to be optimized. If you can basically execute a program in say 10 seconds, you don't want that to be running for like 5 hours or 6 hours, right? So you want your program to be optimized. You want to be writing program in such a way such that you are not doing any extra steps, or the way you are doing it reduces your time of execution, right? That's why we are using a machine instead of actually doing it manually. Okay, so we are not getting any answers still yet. So just a cool trick: if you basically face any such problems where the computer is running a program and it's not actually getting you anything back, and you want to basically exit because obviously you can't do anything. The command prompt hasn't returned yet, so you can't do anything. What you can do is do a keyboard interrupt, and that you can do by using Control plus C. So if I press Control plus C over here, as you can see, I have done keyboard interrupt, and so basically the program was interrupted mid-time. So as you can see, the program was interrupted mid-term. Okay, now so the question remains, so how can I make this optimized? Because why isn't it returning the number fast enough for us? Because if you see, and let me actually show you by actually doing a small exercise. Let's say I am, let's make it over here. Okay. Let's say I am trying to find out f, and by f I basically mean the function, right? So I am trying to find f of 11. So you have seen how we have defined, right? So what is f11? It is f of 10 and f of 9. Simple enough. But now the way our functions have been defined, so we are trying to find out f11, but now you get f10 and f9. The function has to again understand what would be f10. So f10 would be f9 plus f8, right? And there also again f9. What you need to understand is your computer would be executing this thing as well as this thing. So executing f9 would be doubled. So it is a repeating step, right? Once I get f9, if you are doing the maths, you won't be actually repeating this step. But for the computer, the way the code has been written, it would do it f9 plus f8, and again it would do f9 separately. And this would be actually happening quite a lot, because again, if you find out what would be f9, f9 is f8 plus f7. If you see, we have one f8 computation that would be happening again. This would be happening. So there would be a lot of computations which will be repeated. And why it is being repeated? Because the way we have written the function, it doesn't have any memory. Again, repeating, the way we have written our function, going back to our function now, the way this function has been written, there's nothing in the memory, right? So since there's nothing in the memory, so once you get like, okay, f11 is f10 and f9, the function doesn't know, okay, what f10 and f9 is. So it has to basically again calculate what f10 is. There might be f9 over there, but it doesn't getting that answer from somewhere else because it doesn't have any memory. So it actually calculates each and every term that will be produced, and that's why it's taking so long. Obviously, computers can do much faster processing in some cases. These calculations happens very fast in computers rather than human brain, but still it is taking a lot of time to create to do all those calculation, and that's why it's taking so long. So what's the remedy? We don't want that, right? So we want something, or we want a way or an approach where we can actually have that memory, and that is very simple to do in Python. So we will do that. So let's comment this thing out. Instead of actually writing another file, let's comment this one out. You know how to comment, so you can put some hash in. If you put some hash before any line, Python will consider that as a comment. So I just put a shortcut over here so that I can do comment of all those lines, not individually putting hashes. So the way to do that, the shortcut is basically you select the whole thing and you press control and forward slash. Anyway, going forward, so I need to define my function in such a way, and it's still coming. Okay. Now I need to define my function in such a way such that actually I don't need to do this comment, because we can just put another name, right? Okay. Let's just put have this print command as a as comment. Now let's see. Okay. Let's put that over here. Now we will be defining another function, but this time around we would be writing it slightly differently. And we would basically trying to put this in memory. So whatever we are basically calculating, we will try to store it, so that the computer, when it will basically process it, it doesn't have to go back and do that again. It will basically check in that memory. It will check whether this has been already calculated or not, and if it is calculated, it will just give you that answer, nothing else. It will just give you back that answer. And if it is not, then it will do the calculations. Okay. So now let's give another num, fib underscore. So by the way, this is also called, the way we are basically trying to write, this is also called memoization. And you might find this term somewhere else as well, memoization. And this also is called one way of doing dynamic programming, where you actually trying to optimize your code such that it takes lesser amount of time. Okay, let's term this fib mem, right? And similar to the previous case, we would be actually giving just one input, that I want to find the nth term, right? So you would be just putting one input. Now, actually, before moving forward, what we want to do is put one variable outside of the scope of the definition of the function. So let's do call it memo. So it's a variable, it's nothing else. You can name it anything you want, and this would be an empty dictionary. So if you recall one of my earlier videos on data types, so there's data type called dictionary, where you can basically store things in a key and pair value. So let's say I can have data called name, and the name would be say Saurav or something, Ram, Sham, anything, John or anything, right? So the name would be key, and the value would be whatever string I want to put ascribe as name. And you can do that for multiple. So this would be basically a pair-wise values, right? So you would have multiple such pairs. This is how basically dictionaries work. So we would define an empty dictionary, and what we would do is whenever we calculate something, we would basically put that into the dictionary. So now we have put the empty dictionary over here. Now the first line, what I want to write is if in memo val equals to memo, sorry, typo, memo n. Okay, just digest this thing. Actually, instead of doing this, let's actually return directly. Return this value, memo of n. Okay, what I did, this line, this in if n is in a memo, it basically means that it will find that. So what would be our key? Just let me actually show that in the whiteboard over here. So what we are trying to find out is trying to put just trying to put pairs like this. The first term should be 1, the second term should be 1 again. The sorry for that, let's just, yeah, the third term, these are commas, right? So this is the this would be the key, and this would be the value. Again, 2 would be the key, 1 would be the value. Then the third term, again key, it would be 2, and so on and so forth, right? The fourth term, the fourth key would be 3. Like this, it would this dictionary basically would be going on like this. So now going back to the program, what we are doing, before anything else, we are basically checking if we already have this key calculated or not. If it is calculated, we just want to return that. So in a dictionary, if you want to return a value, you can just mention it through a third bracket or a box bracket, a third bracket, square bracket, sorry. So you can just write memo square brackets n, and it would find you the nth key. So wherever the key is n, if there is a value, you would find that. Now what would happen if it is not there? Now you have to write similarly the base cases, like if n is equals to 1, because the base case is not yet done, right? So you have to define the base cases. Then you can define val is say 1. Similarly, if n equals to 2, then also the val would be 1. Else, again the important one, where we are basically considering all the n values which is greater than 2. So if n is greater than 2, then val should be fibmem. Here just remember that our function name is fibmem. It would be fibmem n minus 1 plus fibmem n minus 2, right? Okay, now the last thing, our code isn't finished yet. Why? Because now we have to do the important step where once I find the val, I actually need to write that out. So memo of n. So remember memo, which is a dictionary. Memo of n. The nth term should be this val. Just see whether you have understood everything or not. And now just to write return statement. Now return val. Okay, let's try to understand. First of all, so actually we can actually write val as well. Val would be, since we are returning val. Anyway, the first thing, again, someone can ask like, okay, why you are putting if over here and then if elif over here. So the way I've written it, so this is a separate condition I wanted to first check, and only if it doesn't satisfy this, then only it would go over here, right? If it satisfied it, then we would just return the memo of n. We don't want to even uh, go to any of the other steps. That's why it is written in this way. Usually what happens, if you are just return, if I just put val equals to memo n, then I am just doing a val, right? And then when you basically come into these steps, then the val would be updated, right? So because you know that in Python the variables are mutable, so you can update the variable in a later stage. If say initially you define a variable is at say some number, say 5 or something, and then in a later stage if you basically update it with some other assignment, then it will be updated, right? So that's why I am returning something here, because I want to get out of the function. So if n is in memo, just get out of the function, just return the number and get out of the function. If it is not in the memo already, so memo is basically just a, you can think of it as a memory, right? Memory or cache or something like that. So we are just having a cache or a memory, memory stuff over here, so that you understand that, okay, and how to put it in memory. So the last line is actually where you are storing things in the memory. So let's say I am trying to find out say something like 15. In that case, once you find out f1, it would be stored here. Once you find f2, it would be stored here, so that in the next time you don't have to actually compute that again. So once you store that, and once you basically check for that particular number, you are not checking it for multiple times, right? And now the last thing, whether it's doing its supposed work or not, right? So let's save it over here, and now let's try to print using fibmem. That's what we have named, right? Fibmem. Now we would give a higher number like 50. First of all, let's check with smaller numbers and see whether we are still doing right or not, right? So that's important. Like we might have made some mistakes, so let's just do some smaller stuff where we can just check like, okay, it is working properly. So we are printing fibmem1. Actually fibmem1 is too easy, it should just give you one answer, right? So just save the file over here. Sorry, saved it over here. Now just see python demo. Yeah, and it's coming up as 1. Okay, just seeing that, okay, this print function is actually in comments, so we are only printing this thing. Okay, now if I say fib5, if you remember fib of 5, the fifth term in the Fibonacci sequence is also 5. So again saving it, calling it again, it is coming at 5. Okay, so the initial tests are working good. The last test, if we are trying to find out the 10th term, save it over here, 55. Okay. Initial tests are good. Now let's see whether we have actually made it first or not. Because if you remember, it got stuck when we tried this with the previous function, right? When we tried fib of 50. Now let's see now whether it can do fib of 15. Let's save it. Now again call python. Let's actually do cls once just to clear out the screen. And now python demo.py, and voila, it just came out. You saw how fast it became, right? And the previous time I almost waited for, I guess, 1 or 2 minutes, and it was still not returned any output, but it just gave me an output in probably less than a second. If we even make it much higher, like say if we meme 100, and I guess this will stress it. No, it doesn't. It still doesn't. If even the 100th term of Fibonacci sequence, it's a very big number as you can see, but it's still coming up very, 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 very fast. So you saw the difference, right? The difference between two methods. In the first method, it was okay-ish for like doing simple, like the first 5 or first 10 terms. But when we went up to 50th term of Fibonacci sequence, it kind of like it was running and running and running. It was executing for a very long time, and we actually do not know how long it would take. Whereas the second method, where we actually started storing things, it created a huge impact, because now we are getting, even when we are trying to do f100, it got us results like within a second, right? And just to show you, if we put too many things, then it might be very big number. Yeah, recursion error, maximum recursion depth exceeded in comparison. Okay, now it's actually getting an error, but if we do too much, so just finding out the, yeah, it's getting too much, right? Previously I repeated 995 times, but then it doesn't actually could do anything. Can it be done by for 990? Let's see. Yeah, it still can do for 990. Obviously you can see how big the number is, right? That's why if you go much higher than that, it can't actually return, because obviously computers have their own limit too, right? It can't actually process such that much bigger numbers. For that you need much special computers, not just my laptop won't do it. So anyway, I hope you guys have understood a lot of things. You guys have learned a lot of things. I have actually covered multiple things, right? Because previously I have done if else conditions, I have done for loops, while loops, but we haven't actually used them in context, in a specific context. In this particular video, I have covered how to use if else condition in a specific context, like actually finding out the Fibonacci sequence. And not only that, but I have basically shown you two ways of doing that: a simpler way or brute force approach, and then a much more, I would say, clever approach, which basically kinds of reduces the time of execution. So I hope this would help you in long term. Stay tuned. If you like this kind of video, please like and share it with your friends and families and anyone you know that might be benefited from this kind of video. And until next time, keep learning, guys. Bye bye.